Hello. For this problem, using Excel, it says, suppose the age of children learn to walk is normally distributed with a mean 13 months and standard deviation 1 month. 18 randomly selected people were asked what age they learned to walk. So this first distribution with the capital X, this is the population. And so they want your mean and standard deviation, 13 and 1. The next one, the X with the line over it, that's the sample. The 18 randomly selected people, that's your sample. The sample mean and the population mean are the same. But the standard deviation is not. The standard deviation is, you would put equals, it's the standard deviation divided by the square root of n. So standard deviation was 1 divided by, and then for square root, SQ, we'll bring up the square root. N is our sample size, which is 18. So it's the standard deviation divided by the square root of n when you have a sample. So the mean and the population and the sample will be the same, but the standard deviation is not. Whenever they're saying to use, like this part D says 18 people, then you use part B's mean and standard deviation. And if it does not have the sample, then you use part A's mean and standard deviation. So we'll look at the first, part C. What is the probability that one randomly selected person learned to walk between 12 and 14 months? So with in between, remember you got to subtract them because the 14 will give you the percent below. And then you subtract the 12, which will take this out. It'll leave what's in between. Because it doesn't say a sample, you use part A for the mean and standard deviation. So equals norm distribution. And we'll do the larger one first, 14, comma, the standard deviation, well, the mean and standard deviation. Now, if you want, you could do it at the same time. So then minus norm and the lower value, 12, comma, 13, comma, 1. And oh, that's right. You have to put the area under the curve, which is also 1. So you put the X value, the mean, standard deviation, and then the area under the curve is 1. So then here 12, 13, the first one is the standard deviation, the second one is the area under the curve, which gives us 0.6826. The next one says for the 18 people, find the probability that the average age is between 12 and 14. So you do the same thing, the only difference is the standard deviation. So equals norm, then our X value, which was 14, comma, the mean, comma, and then the standard deviation, 0.2357, comma, 1, close parentheses, minus norm distribution. The 12, 2, 357, comma, 1. Which this would round to 1. If we're going 4 decimal places, 1, 2, 3, 4, that 7 would round this up, so it would be 1. For part D is the assumption that the distribution is normal necessary. Yes, it is normal because it's necessary because the sample size is 18. It needs to be greater than 30. So you do need the assumption of normal. Find the IQR for the average first-time walking age groups of 18. So it's saying the group of 18. So that means we're using the mean and standard deviation from part B. For the quartiles, 25%, it breaks it into quarters. The first quartile is here. So that means 25% of the data is below it. Remember, when you're finding the value, use the percent below. And so equals norm, and then inverse. There we go. Probability, 0.25, comma, the mean, comma. And this was a sample, so we're using part B's standard deviation, 0.2357. 12.841. For Q3 is here, which means that 25, 50, 75% is below it. So when we find the value, we're going to use 75. So equals norm. You want the inverse because we have the percent. We have 0.75, comma, the mean, comma, the standard deviation from part B because it is a sample, 0.2357. And there's your value. And then you just subtract these to get this. So if we take 13.159 minus 12.841, we get the 0.318. Okay, let's look at this one. It's the same problem, different, same things you're looking for. And delete these. The amount of pollutants that are found in waterways near large cities is normally distributed with a mean of 9.6 and a standard deviation of 1.7. 40 randomly selected large cities are studied. Round all answers to 4 decimal places. Okay, so the first one, that's your population distribution, and so the mean and standard deviation were given, 9.6 and 1.7. This is a sample. And the sample was 40 randomly selected cities. The population and the sample means are the same. To find the standard deviation, it's equals the standard deviation from the population, 1.7, divided by the square root and then the sample size, which was 40. Yeah. So when it's using the sample of 40, you use part B. Part A does not. What is the probability one randomly selected city's waterways is more than 9.3? Okay. When we find the percent, it's giving us less than, so we could take 1 minus our answer because we're going to get below, we want above, so you want to take 1 minus it. Norm distribution, the x value was a 9.3, comma, the mean was 9.6. And the standard deviation, this was not the sample, so we used the 1.7. and the area under the curve. The second one uses the 40 cities. So the only difference is the standard deviation. Instead of the 1.7, it'll be the 2688. So we'll go equals 1 minus the norm distribution. Whoops. The x value, which was 9.3, comma the mean 9.6, comma standard deviation from part B 0.2688, and area under the curve is 1. Sometimes if you forget to close the parenthesis at the end, it will tell you. But there's your answer. For part D, is the assumption that the distribution is normal necessary? No, it's not, because the sample size is more than 30. It's 40. And because of that, then you didn't need it. For the quartiles, remember 25%, the first quartile is right here, so 25% is below it. So we use equals norm, and we're using the inverse because we're finding the value. Percent below, 0.25, comma, the mean, 9.6, comma, and then this was the sample that said 40 cities. So we use 0.2688. And there's our value. For Q3, 1, 2, 3, these three are below it, 75%. So equals norm, inverse, and then 0.75, comma, the mean, which was 9.6. This was the sample. So we use part B's standard deviation, 0.2688. There you go. And then you subtract these two to get this one. So Q3 minus Q1 is this.